All right, gentlemen. So we are working with high-speed counters today in TIA Portal. All right. Now, the first question I have for you all is, why do we need high-speed counters? We've got counters in the program, right? We can make them just increment by one. Why do we need high speed? All right. Let's think about it this way. If your code is running as efficiently as possible, which in this class we are probably pretty close to that, you're running at maybe 1 millisecond per second loops. 1 millisecond loops. All right, so it takes 1 millisecond to run your entire code before it runs your entire code again. All right, that means your code is running 1,000 times per second. If that counter block needs to see a low signal to a high signal for it to count up one, all right, that means we have to take two loops, right? Because we have to go from a low loop, next loop has to be high, loop again has to be low, loop again has to be high. All right, so at our best, with a normal counter in our code, you can count 500 times per second. All right, that's got some pretty good speed to it. All right, but if your code's running slower, maybe say 3 or 4 milliseconds, now it's 8 milliseconds before you can count. All right, now all of a sudden now it's what, like 125 times per second. All right, so that can drop drastically. Now, if we look at these counters that we're using, they say, if we go to the very last page of this, here is our encoder information for our motor. But if we look down here, it says frequency is a max of 1 kilohertz, so 1,000 times per second. So if we only can count 500 times per second, we're going to be missing pulses, what it comes down to. All right, and this is why we need high-speed counters. All right, for things that are happening faster than the PLC code is able to interpolate. All right, so for example, let's say you've got bottles running down the line. You're trying to count how many bottles you've produced. Well, if you've got them on a high-speed machine that's just cruising by, you can't count them all fast enough. So we actually have dedicated hardware for counting them. Now, in this instance, with the S7-1200s, it is built into the PLC itself, which is nice. And what happens is there's a little interrupt that gets thrown. So every time that input will go high when we have a high-speed counter enabled, the interrupt gets flagged, and the PLC kind of pauses what it's doing, counts, and then goes back to what it was doing again. All right, so really nice in that aspect. Sometimes these are add-on modules. All right, so the 1769 Allen Bradleys we have up the hill, those don't have the capability for high-speed counting built in, but we could get a module that we would add on to it, so we actually would then have that capability if we would want it. And that was my plan at one point, but that plan has gone the wayside. So we've got the Siemens, they've got it built in, and I think my new Micro 800s have it built in as well. So that's nice that we can do this with either one of those. But anyway, there's also two different types of counters. All right. So traditional rotary encoders are actually pretty simple in the long run. All right. So here you can see we've got a simple disk. All right, that has holes through it basically. All right, and you can also see we've got two little sensors here. All right. So when input A is lined up with this hole, it's true. When input B is lined up with that hole, it's true. All right. So you can see as we would rotate this slightly. Get my pen out. This hole would start to move down. Am I not drawing? Oh, that's lovely. Don't know why I'm not drawing. Oh, I guess my drawing's not going to work today. Anyway, this hole would come down and we'd go over that. So A would go true first, and then it would come over B. They'd both be true. Then A would go false, so B 0, and then B would go false. So it's a very pattern of both false, A true, both true, B true, both false. All right. And if we spin it the other direction, it would go both false, B true, both true, A true, both false. All right. So you can actually tell which direction you're spinning that encoder based on the pulses that are coming out, which order they're in. All right. And down here at the bottom, you can see it. You can see how it's blue is true by itself, then both, then green, then neither. All right. So you can actually track that. And it's a really simple system. Now, it does involve two inputs, all right, but it's a digital input instead of an analog, so we don't have to have like an 8-bit ADC, which would be 8 bits of input. So it allows us to track rotary motion very nicely, right? And this is how most dials are nowadays. If you can spin a dial forever, it's going to be a rotary encoder, all right? Older dials that used to spin, that have a hard stop on the left, and then you'd spin it almost 360, like 300 degrees, and there's a hard stop on the right. Those would be potentiometers. Those are straight up analog devices. But for our purposes, encoders are actually, to me, a much nicer system, and they're much more useful. long run, because you can just keep spinning them. It doesn't matter where you are. You're like, just spin to the right. You can like increase volume, you know. Then you could decrease volume somewhere else. Then you can increase volume here again, and it just allows you to keep turning it to the right. It's not like, oh, causes problems. So anyway, this is basically what's going on inside that motor. We've got a little disc. Now this disc has a lot more little slots in it than 6. All right, but it still has those slots and whatnot. So in TIA Portal itself, you guys hopefully have got your inputs made. If not, you will get them. All right, so here you can see all of my inputs. Now, we don't actually need to make these encoder inputs. All right, I'll show you why in a minute. Yeah, it seems kind of stupid, right? You're like, and I agree, it's horribly stupid to me. You should have to make the encoder inputs. Or you should be able to use those tags later, but we have to tell it hardware which our inputs are, not be a tag. So, I mean, it'd be nicer to be the tag, so that if I had to change something, I could change it here, not in the menu, but that's just how the game works. Anyway, we got my inputs made. We don't have to make the encoders. I just put them in there for placeholders to remind me those are used, but I'm never going to actually use those. We can, however, see them actually spinning. So I've got those highlighted right now, and if I tweak this ever so slightly, you can see one goes true, then the other. And again, like, you have to move this such a little amount for these things to go true. Really kind of annoying. All right, if you actually would look at the PLC itself, which I can't get close enough to the camera, those lights are flashing like freaking crazy. Like a little Christmas tree show, which is how fast they're cranking. And I think when you run the motor, they basically just look like they're constantly on. All right, so anyway, kind of an interesting thing. But anyway, please follow along if you want to for setting up the high-speed counters. So first we need to do is we need to go to our PLC properties. Let me go ahead and drag this up here and let's zoom in on it. Boom, there we go. All right, so right off the bat, you actually probably all see HSC 1 and 2, 3, 4, 5, and 6. So we can actually have 6 different high-speed counters on this, which is very convenient, although not actually necessary. But we can have them. So we're going to be using 2 of them. All right, but before we even do that, I've talked to you guys about this before. All right, but we have filters on our inputs here. All right, and what that means is before, oh, I gotta go offline. Before the PLC qualifies an input as true, it has to wait 6.4 milliseconds. And it does this to make sure there's no electrical noise causing false positives. All right, now can we go longer? Yes, you can go up to all up to 20 milliseconds. You can also go all the way down to 0.1 microsecond. All right, now for those who do not know, it's milli, then micro. So milli is times 10 to the negative third, or 0.001 seconds. Micro is 10 to the negative 6, or 0.000001 seconds. So super small. All right. Do we need to go all the way down to micro for this purpose of this? No. All right, we do not need to. But we're just going to. All right. Ideally, you would take this down to the point that you need to and not any farther to help reduce those false positives. All right, that does say it's max of 1 kilohertz, which would be 1 millisecond. All right, so in theory, 1 millisecond would be fine. We could just take it just a little bit below 1 millisecond here, so we get down to like 0.8 milliseconds. That would be perfectly fine. So yeah, I'm going to try that. We'll go down to just 0.8 milliseconds. Actually, not in this one though. All right. So what we need to do is you need to figure out which inputs are your encoders. So in this case, we have 3, 4, 5, and 6 is how I have mine wired. So channel 3. I need to bring down to, again, less than a millisecond, and 4, take down there as well, 5 and 6, so all 4 of them need to go down to that less than that. All right. Now, the other thing I do like to point out here is on input 0, you have down to 0.1 microseconds. If we go out here to input channel 13, you only go to 0.1 microsecond. Something was different, I thought. Oh, I guess I just lied to you guys. There was one reason that I like the lower ones, but I don't remember what it is now. It's on my head, so doesn't matter. All right, so anyway, so we reduce those filters. Now these inputs will go faster, so the PLC will actually detect them how they're supposed to. All right, so it's hopefully at least. Now we need to go back to those high-speed counters. All right, and I'm going to do this one at a time. So high-speed counter 1, general. Yes, we want to enable this. All right, and you can give this a name if you want to. So I'm going to go with, this will be for my inputs 3 and my 4, this is going to be my vertical. All right. On our trainers, we only have 2 high-speed counter motors. Why they didn't put a third on, I don't know. My guess is they ran out of I/O to use. All right. Because if you notice, we go all the way up to 15 or 14 for our inputs. So we got 10 inputs on this board. I think they allow 10 outputs basically. So we're already using all the inputs. So I think that's why they didn't do any more. That's my best guess. All right, so I named mine vertical. You don't have to. Make sure you do enable it though, otherwise it's not going to work. Next, we have to go to function, and we do want this to be count. All right, and then the operating type. We do an A/B counter. All right, and that is what I just showed you guys a picture of. So this would be an A/B counter. You see, we have an A and a B, so we've got two options there. All right, so we will do A/B counter. All right, you have single phase. Also, if you look at here, we've got a period, frequency, motion control. But for our purposes, just count's good. Again, single phase, two phase, AB fourfold. We just have an AB counter. And their initial counting direction, you can say up or down. That is your personal preference. All right. I have found this to be very annoying. In theory, you can change the direction of count in software, with a function block. I've never had that be successful, but I'm not perfect with this software. So once you know a little bit more than maybe I do, you can get that function block to work. But I have done a very bad job of that. All right, anyway, we're set to initial values. All right, so our initial counter value is going to be 0, initial reference value 0. We can use an external reset for our input. All right, and I'm going to say, no, we're not going to do that. Not right now. All right. Actually, yeah, we will. We'll use an external, an active high. All right, and the reason we said we can do that is because we have limit switches on our robot here. So if I scroll back up a page, all the way to the top. So we're doing this vertical axis right here. So you can see I5 at the top is a limit switch, and that will be our reset point. Once we get all the way to the top, that switch will get pressed. That will reset our counter for us to make sure that we have an accurate count every time we home, take this thing back to the limit switches. All right. So you have to know what I5 is, obviously, but we'll come back to that in a minute. All right. So active high. We have event configurations. We're not really ready about that. Hardware inputs. This is important. So clock A input, for me, that will be 0.3. I'll just select that. And then this will be 0.4. And then my reset for my vertical is 1.3. So I'm going to go ahead and select that as well. All right. So I've got those input. Again, whatever you guys have, you'll have to set those specifically to your program for high-speed counters. But for my purpose, those are what I have. That's why I have my tag table pulled up. Not that you guys can see it, but I do have my tag table right here so I can see what is going on for my addresses. Wrong button. This one. All right, next we have our I/O addresses. All right, now 1000 is perfectly fine for this. We're not even going to touch that one. And then our hardware identifier 257 if we need it. So we've got our high-speed 1. I'm going to quick go through and set up high-speed 2 for the same thing. Instead of vertical, I'm going to call this one vertery because that is what we've got. My function again will be count. We're going to do A/B counter. Counting up is what I want. We're going to use a reset for our input. Our hardware now for my turntable is 5 and 6. Then select those. 6, and I do have a turntable reset home switch, so that's 1.4, so I'll select that one. My address here, notice this one's 1004. All right, so we're higher now. It's by default, it knows that. And again, same with our hardware identifier. All right, and in theory, that is all we need to set up so we can actually have our high-speed counter working here. It is awesome. All right, so I'm going to go ahead and say okay to that. Now, to make my life easier, let's go ahead and add a new tag table here. And I'm just going to call this one encoders. So I am going to add this encoder. So I'm going to say vertical count. All right, data type. I think this is a dint is what we want. And my address is ID 1000, if you remember. Then my rotary count. Dint, and this is ID 4000. So there we go. So in theory, yeah, can't see. Damn it, I always do that. All right, so I just made a new tag table called encoders. And then I named it rotary count and dint, and then ID 1000. That was the address. All right. So how do we know it's ID? Well, it's an input. All right, and then it's a double word double. So that's why it's the D. All right. And in theory, again, if we would actually come and look at our assignment list, we don't see it because, well, we're not using them because, lovely things. But anyway, we'll get there. Don't worry. Anyway, so now if I go back to my PLC, let me just go ahead and download my code, and hopefully we should be able to see those counters counting when I rotate some things. Go ahead and load this. All right, so I've got it loaded. We are overall in good shape. I went into my tag table and I said sunglass mode, so that way I could see what's going on. Let me go ahead and slide to my right. So here are my monitor values. Now I'm going to spin my vertical axis by hand. And you can see that we've got it going negative, and if I go the other way, it goes positive. Hard to spin the other way because of turning something loose. And the same thing happens on my bottom one if I spin that by hand. Let me, there we go, we can see that's counting. And if I press those limit switches, it will reset them back to 0. All right. So, high-speed counters. They're not complicated to get set up. To me, the most annoying part is the direction. Right? And as I said, right now, I don't have a solution for flipping the direction. The things I've tried in the past using the high-speed counter function block control hasn't worked. All right. Now, I'm going to pause this video and I'm going to attempt to get that to work. And if I get it to work, I will record it. And if not, you're not going to see anything. So I will, though, give it my best shot, see if I can figure out how to get that working before I post this video. So I'll see you in a few seconds or in the next video.